This is really going to be short because we're not going to beat a dead horse, if you will. We're going to look at graphing logarithmic functions. We have log base b of x to the minus h plus k. You could also put an a out here and have a vertical stretch or compress. The line x equals h is a vertical asymptote. If you don't add or subtract anything to x, then x equals 0 is a vertical asymptote. The domain is x greater than h, and the range is all real numbers. If the base is greater than 1, the graph moves up to the right. If 0 is less than b, which is less than 1, then the graph moves down to the right. So let's take a look at some of these. First off, I do want to show you, maybe. Here we go. I want to show you what the parent function looks like. So function, insert, oops, that's it, nope, log of x. Okay, so notice it goes up, right to left. Okay, a log is the answer, the y values are your exponents. So, nope, not gonna do that. Nope, close, go away. Here we have graph the following functions, state the domain and range. And notice that my base, instead of being a value greater than, it's less than 1. So b is less than 1, so it's going to go down left to right. X equals 2 is the vertical asymptote because it's moved 2 to the right. The domain, x is greater than 2. The range is the all real numbers. And then you can calculate a couple of points. F of 5/2 is equal to 1, f of 3 is 0, f of 4 is negative 1. How in the world did I get those so quick? Let's look. If I put in 5/2 over here, this is going to be 5/2, and 2 is the same thing as 4/2, right? So I actually have log base 1/2 of 1/2. Well, remember, what do I raise 1/2 to get 1/2? It's 1. Okay, got it. Next up is the next one. If I plug in the value 3, well, 3 minus 2 is 1. So I need log, oops, sorry, we'll do the G there, log base 1/2 of 1. What exponent do I put on 1/2 to get 1? That's 0. Okay? And then the last one, if I plug in 4 right here, that's going to make it 2. So I'm going to have log base 1/2 of 2. What exponent do I put on 1/2 to get 2? Negative 1. So then I can take these x values and these y values and plot them. I know where my vertical asymptote is, and so I can just draw this curve. It's going to keep going down forever and up forever, but it's never going to, x can never go below 2. Okay, and if you want to understand why, think about this. If I put a 1 in here, then that means I have log base 1/2. 1 minus 2 is negative 1. This says I have a positive base. What exponent can I put on a positive base to get a negative number? You can't. If I have a positive number times a positive number times a positive number ad infinitum, I can never get a negative number. So it doesn't exist. It's undefined. Okay? Let's look at another. Oops. Sorry. I think I had, yes, I had a second one there. Log base 2 of x plus 1 plus 2. So b is greater than 1. 2 is greater than 1. Let's use a pen instead. Okay? B is 2. It's greater than 1, so it's going to go up to the right. It's got this shape. X equals negative 1 is the vertical asymptote, because this is x minus negative 1. So the value of h is -1, meaning that it went to the left 1. Domain, x is greater than -1. It's going to be all these things here. The range is all real numbers, but it also moved up 2. So I took this and I went 1, 2, 1, 2. I just took every point from the parent function and moved it up 2. Okay, and then I calculate a couple of points. Again, I put in things like 1. 1 plus 1 is 2. The log base 2 of 2, okay, is, oops, sorry, I put in the 0 there. Okay. I'm confusing myself. I've got too much stuff here. Let's do this. Boom, boom. Okay, -1/2. If I subtract a half, then I wind up here with log, I'm going to leave this here, log base 2 of 1/2. The log of 1/2 is -1 plus 2 is 1. Then I'm going to come along and say, great. Now I'm going to put in a 0. So log, if I plug a 0 in here, base 2 of 1, that's going to be 0, but then I add 2. That's where I get the 2. If I put a 1 in here, 1 plus 1 is 2. Log base 2 of 2 is 1, plus 2 is 3, and so on. So I get a couple of points, and I can graph my line. I could also come in here and do the little dashed line. This is really hard with a mouse. My vertical asymptote. Okay? And again, a lot of it is just being able to state what you're doing, how you're doing it. Okay? That's it.